Hello children, I've already posted the link for you from problem 1 to 10 as said in earlier video. So here, if you have any doubt, you can write your comment in the comment section if you need an explanation of any problem from 1 to 10. In problem set, we are going to start with 11th problem. Show that points P, Q, R, S, the coordinates are given, are the vertices of a parallelogram. As you know, by distance formula, we can calculate the distance PQ, QR, RS and PS. So here distance PQ equals to 4 root 2, QR equals to root 13, RS equals to again 4 root 2 and PS equals to root 13. Here you can solve by distance formula or by slope method also. In quadrilateral PQRS, PQ equals to RS from 1 and 3 and QR equals to PS from 2 and 4. Therefore, the quadrilateral PQRS is a parallelogram. A quadrilateral is a parallelogram if both the pairs of its opposite sides are congruent. Therefore, points P, Q, R, S are the vertices of parallelogram. Here in problem set, as you have seen that I am not going to explain every step here. The reason is that you know how to make use of the distance formula. Next, question 12. Show that the quadrilateral PQRS formed by the points given is a rectangle. So again by distance formula, we'll calculate PQ equals to root 13, QR equals to root 52, RS equals to root 13 and PS equals to root 52. In quadrilateral PQRS, PQ equals to RS from 1 and 3, QR equals to PS from 2 and 4. Therefore, quadrilateral PQRS is a parallelogram. A quadrilateral is a parallelogram if both the pairs of its opposite sides are congruent. But if I want to prove it rectangle, then diagonals of the quadrilateral must be congruent, of parallelogram that is, must be congruent. So here we will calculate the distance PR and QS. Both are the diagonals. So here we get distance PR equals to root 65 and QS also equals to root 65. In parallelogram PQRS, PR equals to QS from equation 5 and 6. Therefore, quadrilateral PQRS is a rectangle. A parallelogram is a rectangle if its diagonals are equal. Next question, 13. Find the length of the medians of a triangle whose vertices are A, B and C. Their coordinates are given. Here you can see this figure. In geometry, draw the figure because it is for ready reference for yourself also when you are solving. At the same time, for the valuer also, it goes easy to refer the figure and evaluate. So suppose AD, BE and CF are the medians as shown in the diagram. Therefore, points D, E, F are the midpoints of side BC, AC and AB respectively. Now, by midpoint formula, we'll calculate the coordinate of point D, E and F. So, coordinate of D will be with respect to, here you can see the diagram, B and C. Midpoint is D, A and C, midpoint is E, and with respect to coordinate A and B, F is the midpoint. So here, coordinate of D According to that, substitute the value, you get 8 by 2 and 2 by 2, that is coordinate of D is 4 and 1. Coordinate of E will be 1 and 3. Coordinate of F will be 2 and minus 1. This coordinates of D, E and F we can calculate by midpoint formula. After that, we have to find out the length of the medians. So, distance formula will apply. So, AD equals to 5 by distance formula, B equals to 2 root 13 and CF equals to root 37. Therefore, the lengths of the medians of the triangle are 5, 2 root 13 and root 37. Next problem, question 14. Find the coordinates of centroid of the triangle if points D, E, F are the midpoints of the sides of that triangle. Centroid, you know, that is nothing but AD, BE and CF are the medians. Intersection of the three medians is known as centroid. Again, the figure is drawn here. Centroid is denoted by G. Suppose A x1 y1, B x2 y2, C x3 y3 are the vertices of triangle, as they are not given, and here midpoint is given. So what we will do, D, E, F are the midpoints of segment BC, AC and AB respectively are given. Their coordinates are given. So let G be the centroid. So coordinates of D equals to, substitute the values of x2, x3 upon 2, y2, y3 upon 2. Simplify. Here you will get coordinate of D will be minus 7 and 6. Therefore, x2 plus x3 upon 2 will be minus 7. y2 plus y3 upon 2 will be 6. You will get x2 plus x3 equals to minus 14 by cross multiplication here. By cross multiplication here, you will get y2 plus y3 equals to 12. Now, these are equation number 1 and 2. Here you will come across, they are in two variables. Each equation is in two variables. Different variables are there. We will relate it later on. E is the midpoint of segment AC by midpoint formula. Again, coordinate of E equals to coordinate of the other 2 points. Then 8, 5 are the coordinates. Therefore, x1 plus x2 upon 2 equals to 8. y1 plus y2 upon 2 equals to 5. Again, two equations we are getting in two variables, that is x1 plus x3 equals to 16, y1 plus y3 equals to 10. Let these equations be 3 and 4. F is the midpoint of segment AB by midpoint formula. Coordinate of F are 2 and minus 2. Related to that, the points will be x1 plus x2 upon 2 equals to 2, y1 plus y2 upon 2 equals to minus 2. Again, you are getting two equations with different variables. x1 plus x2 equals to 4, y1 plus y2 equals to minus 4. Equation 5 and 6 respectively. Now here you see what we are doing. All the x coordinate variables equations we are adding 1, 3 and 5. These three equations from above we are adding. So we are getting x2 plus x3, x1 plus x3 plus x1 plus x2 equals to minus 14 plus 16 plus 4. So indirectly 20 minus 14 is 6. And here twice x1 plus twice x2 plus twice x3. Dividing by 2 to each term, we will get x1 plus x2 plus x3 equals to 3. Equation number 7. Adding the y coordinates equations, we will get similarly twice y1 plus twice y2 plus twice y3 equals to 18. Let this equation of y variable be 8. G is the centroid of triangle ABC. By centroid formula, you know very well centroid formula. The 3 vertices x coordinate divided by 3 and 3 coordinates of y, their addition divided by 3. So centroid formula is x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3. From equation 7 and 8, we get the values 3 by 3, 9 by 3. So here we get answer 1 in 3. The coordinates of the centroid of triangle are 1 and 3. Problem is very easy, only little bit more steps are there. But once you understand the method, you can work out step by step. 15th problem. Show that coordinate of points A, B, C, D are given are the vertices of a square. Again, by distance formula, here it is explained. Distance AB equals to root 5. Distance BC equals to root 5. CD equals to root 5. AD equals to root 5. Therefore, AB equals to BC equals to CD equals to AD from equation 1 to 4. Therefore, all sides are equal of a quadrilateral means it is a rhombus. Now, we have to show that in rhombus, you know the properties of the rhombus, all sides are equal, but diagonals are not congruent. If they are congruent, then it becomes a square. A rhombus, if diagonals are congruent, then it becomes a square. So we'll find out the diagonals here. Distance AC and BD, these are the diagonals. So here distance AC equals to root 10 and distance BD also equals to root 10. In quadrilateral ABCD, AC equals to BD from equation 5 and 6. Therefore, quadrilateral ABCD is a square. A rhombus is a square if its diagonals are equal. Problem number 16. Find the coordinates of a circumcenter and radius of circumcircle of triangle ABC if coordinates of point A, B and C are given. Suppose O is the circumcenter of a circumcircle here. The figure is given for reference there. Let O's coordinates be x coordinate be h and y coordinate be k. How you get circumcircle if you know? When we bisect the given sides of a triangle, means OA equals to OB equals to OC. When the three vertices are equidistant from O, then it can draw a circumcircle. So here OA equals to OC, radii of the same circle. Therefore, substitute the value by distance formula OA, distance formula OC, square root, both the sides are there. By taking square on both the sides, root sign will be removed. Take the expansion of h minus 7 square plus k minus 1 whole square equals to h minus 2 whole square plus k minus 0 square. It will be k square only. And after simplifying it, we'll get equation 10h plus 2k equals to 46. Divide by 2, 5h plus k equals to 23. Similarly, OB equals to OC. First we have taken OA equals to OC. Now we are taking OB equals to OC. Radii of the same circle. Same method, distance formula. Taking both the sides, square root is there. Taking square of both the sides, we get the equation h minus 3 whole square plus k minus 5 whole square equals to h minus 2 whole square plus k minus 0 whole square. Expand the terms, and after that simplifying it, you will get 2h plus 10k equals to 30. H plus 5k equals to 15 after dividing it by 2. Multiplying equation 1 by 5, we get 25h plus 5k equals to 115. Here why it is multiplied? Because we have to solve simultaneously these two equations, first and second. So subtracting equation 2 from 3, we get 25h plus 5k equals to 115 minus h plus 5k equals to 15. As we are subtracting, sign changes. Therefore, 24h equals to 100 because plus k plus 5k minus 5k got cancelled. So h equals to 100 upon 24 equals to 25 upon 6. Substituting the value of h in equation 1, we get, as you know, in simultaneous equation, when we solve, when one variable is known to us, we can substitute in any equation and get another variable. So here, value of h in equation 1 we are substituting here. So 5 into h, that is 25 by 6 plus k equals to 23. Simplify this, 23 equals to 5. 25 is 125 upon 6. This side it was plus, so here it will be minus 23 into 6 you do, minus 125 upon 6. Answer will come to 13 upon 6. So coordinate of O, H, K are 25 upon 6 and 13 upon 6. To find the radius of the figure, we take distance OC or any other OA or OB also you can take. OC is taken. By distance formula, substitute the values here. You will get 13 root 2 upon 6 units. Therefore, the coordinates of the circumcenter of the triangle are 25 by 6, 13 by 6, and radius of circumcircle is 13 root 2 upon 6 units. Next problem 17. Given A, B are the 2 points whose coordinates are given. Find the coordinates of the point that divides segment AB in the ratio 3:1. Here which formula you will apply? Correct. Section formula. I am sure you might have thought section formula only. Suppose point C divides segment AB in the ratio 3:1. Coordinates of A are x1, y1, that is 4 and minus 3, and coordinate of B is x2, y2, that is 8 and 5. By section formula, x coordinate of C will be, substitute the value in the section formula, you will get 28 by 4. X coordinate of C will be 7. 28 by 4 is 7. Y coordinate of C, substitute the value in the section formula, you will get y coordinate of C equals to 12 by 4, that is 3. The coordinates of the point dividing segment AB in the ratio 3:1 are 7 and 3. 18th problem. Find the type of a quadrilateral if points A, B, C and D are joined serially. They are joined serially, means in order. So we will come across, we will find out the slope of AB, BC, CD and AD. So slope of AB you know very well, y2 minus y1 upon x2 minus x1, that is coordinates of point A and B. Everywhere it is written y2 minus y1 upon x2 minus x1, that is the slope formula, but these are the coordinates of the points here. So here if you simplify, slope of AB equals to minus 5, slope of BC equals to 5 by 6, slope of CD equals to again minus 5, and AD equals to 5 by 6. As slope AB equals to slope CD, therefore line AB is parallel to CD. Slope BC equals to slope AD, therefore slope BC equals to slope AD, therefore line BC equals to line AD. Both the pairs of opposite sides of quadrilateral, this must be, are parallel. Therefore, quadrilateral ABCD is a parallelogram. Next point, question 19. The line segment AB is divided into 5 congruent parts at P, Q, R and S such that A dash, P dash, Q dash, R dash, S dash, B. That means point P, Q, R, S are lying between A and B in order. If coordinates of point Q and S are given, find the coordinates of point A, P, R, B. You know that how many parts it is divided? 1, 2, 3, 4, 5. So points P, Q, R and S divide segment AB in 5 congruent parts. Let the coordinates of A be x1, y1, B x2, y2, P x3, y3 and R x4, y4 be the given points. Point R is the midpoint of QS. By midpoint formula, x coordinate of R is coming as, it must be 16 by 2, that is 8. Y coordinate, here it is 32 by 2 equals to 16. Therefore, the coordinates of R are 8 and 16. Here it must be 16 by 2 and 32 by 2. So, therefore, coordinates of R are 8 and 16. Point Q is the midpoint of segment PR. Therefore, by midpoint formula, coordinate of Q equals to x3 plus 8 upon 2 and coordinate of Q is 12. Simplify this equation, you will get x3 equals to 16. Coordinate of y coordinate of Q is y3 plus 16 upon 2. So 14 equals to y3 plus 16 upon 2. Cross multiply, you will get 28 equals to y3 plus 16. Therefore, y3 equals to 12. So coordinate of P, x3, y3 will be 16 and 12. Point P is the midpoint of segment AQ. In the diagram, you can refer. Therefore, midpoint formula, x coordinate of P is x1 plus 12 upon 2. So again, cross multiply here, 16 2s are 32, x1 plus 12 upon 2 equals to 16, cross multiply, 32 equals to x1 plus 12, x1 equals to 20, y coordinate of P equals to y1 plus 14 upon 2, 12 equals to y1 plus 14 upon 2, cross multiply, it will be 24 equals to y1 plus 14, y1 equals to 10. Therefore, A x1 y1 equals to 20 and 10. Coordinates of A x1 y1 equals to 20 and 10. Point S is the midpoint of segment RB. By midpoint formula, again x coordinate of S is x2 plus 8 upon 2 equals to 4. Simplify it, x2 equals to 0. Y coordinate of S is given 18 equals to y2 plus 16 upon 2. Simplify it, y2 equals to 20. Therefore, coordinate of point B, x2, y2 will be 0 and 20. The coordinates of the points A, P, R, B are 20, 10, 16, 12, 8, 16 and 0, 20 respectively. Problem number 20. Find the coordinates of the center of the circle passing through the points P, Q and R. Suppose center is O, H and K are the x and y coordinate. So here, red I have the same circle. same method as above, what we have solved. You have to simplify this. Here you will get 6h plus 2k equals to 14. Divide by 2, we will get 3h plus k equals to 7. Again take OP equals to OR, radii of the same circle. Again you will get the equation 6h minus 18k equals to 54. After simplification, again dividing by 2, you will get 3h minus 9k equals to 27. Now, two equations you got with two variables h and k. Solve the equation. Subtracting equation 2 from 1, we get 3h plus k equals to 7. Subtract 3h minus 9k equals to 27. You will get 10k equals to minus 20. Therefore, k equals to minus 2. Substituting the value of k in equation 1, we get 3h minus 2 equals to 7. Therefore, 3h equals to minus 2 will come this side and it will become plus 2. That will be 7 plus 2, 9. And 9 divided by 3 is 3. So, value of h will be 3. The coordinates of the center of the circle are 3 and minus 2. Next problem 21. Find the possible pairs of coordinates of the fourth vertex D of the parallelogram if three of its vertices are A, B, C. Your figure is very important, students. Here you see, here triangle ABC is given. Got it clear? D can be on this side towards the AB. So quadrilateral will become DACB. Do you agree with this? Yes. If D1 is down on the side of BC, then quadrilateral will be D1, B, A, C. Another quadrilateral. Third possibility, if D point is on AC side, then it will be D2, C, B and A quadrilateral. Got it? So D, D1 and D2 are the three possibilities of the points D by which the vertex A, B and C will make a quadrilateral. I am sure this point is clear. So here let the points A, B, C are the three vertices of the parallelogram. The fourth vertex be D, D1, D2 as shown in the figure. So here are the coordinates. Let the coordinates of that D be x1, y1, x2, y2 and x3, y3. This is D1 here. Consider the parallelogram ABCD. The diagonals of a parallelogram bisect each other. Therefore, midpoints of DC equals to midpoint of AB. D coordinate is given, C coordinate is given, A and B coordinates are given with variables they may be. So substitute the values here. You will get this equation and here you will get the equation and simplify it. So here x1 plus 3 upon 2 equals to 6 by 2, that is 3. This 2 gets cancelled. Sorry, I am not cancelling 3 here. Denominator 2 will get cancelled. Here also denominator 2 will get cancelled. So here x1 plus 3 equals to 6. Y1 minus 2 equals to 4 because denominator 2 got cancelled. So x1 equals to 3 and y1 equals to 6. Coordinates of point D x1, y1 are 3 and 6. Now consider the parallelogram AB D1C. Method remains the same. Midpoint of A D1 and midpoint of BC you have to take. Method remains the same, only values will change. So here you will get x2 plus 5 upon 2 equals to 4 by 2. Denominator 2 gets cancelled. x2 plus 5 equals to 4. So x2 equals to minus 1. Similarly, here also y2 plus 6 upon 2 equals to minus 4 upon 2. Denominator 2 gets cancelled. What is left? Y2 plus 6 equals to minus 4. Therefore, y2 equals to minus 10. Coordinates of D1, x2, y2 will be minus 1, minus 10. Now consider the parallelogram ABCD. 2. The diagonals of the parallelogram bisect each other. So midpoint of BD2 and midpoint of AC. We are also considering the diagonals only. So here, after considering that, you will get the D2 coordinates x3, y3 are 7 and 6. So the possible pairs of the coordinates of the fourth vertex D of the parallelogram are 3, 6, minus 1, minus 10, and 7 and 6. Next problem. Question 22. Find the slope of the diagonals of quadrilateral with vertices A 17, B 63, C 0 minus 3, and D minus 3, 3. Solution. Suppose ABCD is the given quadrilateral. Therefore, slope of AC equals to 10, slope of BD equals to 0. Therefore, the slopes of the diagonals of a quadrilateral are 10 and 0. Here we have to find out the slopes of the quadrilateral, diagonals of the diagonals. So very clear. Here we end the chapter 5. In the next video, we'll move to chapter number 6. Till then, take care of yourself. If any problem is there, you can write in the comment section. I will try to clear that doubt in the next video. In the description, 5th chapter notes will be available for your ready reference. Use them. Thank you.